Okay, cool. Thanks, everyone. So my name's Arthur Bigeard. I'm going to be here today to talk to you not about super complex stuff, but actually more about the stuff that we should make like less complex for graph database users. And so my focus area is on providing the right tools for developers that are going to interact with graph databases to be able to build the right feedback loop around their work to be able to both learn the language and the concepts, but then also to build increasingly complex queries and workloads, et cetera, et cetera. We build tools that are basically addressed for beginners and experts alike. Just quickly about me. So my name is Arthur Bigeard. I'm the founder of G.V. So always address that, it's pronounced G.V. We've got a very strong Apache Tinkerpop heritage. That's actually the reason behind the name. It's based on the Gremlin querying language, which is an excellent graph database language, but it's also one that's relatively difficult to learn and that suffers from a severe lack of tool, which has sort of been the whole reason why we made G.V in the first place. So we started out as this tool that would make querying Apache Tinkerpop-based databases with a Gremlin querying language a lot easier, and then realize, well, compatible with labeled property graph, there's a whole bunch of those, and there's a whole bunch of languages. Why don't we just start expanding all that? And so, of course, because GQL has been released as a standard, and we are now seeing graph database vendors adopt the GQL standard, there's an issue that is going to start cropping up that we're perhaps not fully addressing, which is going to be that when users are going to interact with those graph databases using GQL, what they're going to use, and how can we help them make their life easier getting up to speed with the language. Of course, there's been a lot of work done around making it as cipher similar as possible, so there's a little bit of work that's been done there, but nonetheless, if we look at the sort of broader picture of databases, these user interfaces have always existed to make people's life easier. And so today I'm going to be presenting the work that I've been doing on integrating GQL. I'm using Altigraph for the demonstration simply because Altigraph at this point has demonstrated a fairly high level of compliance with GQL, and that therefore makes it a very good database to do the demo with. Before I do the demo, I want to show you a quick screenshot. This is a relatively old application that you've maybe used at some point in your career or as a student. This is Oracle MySQL Workbench as an integrated development environment for relational databases. And this screenshot encapsulates a lot of the stuff that users don't necessarily know they need, but when they put their hands on it and start working with these tools on their database, they're just going to be a lot more dangerous, generally speaking. So what we're seeing here is this desktop application that allows you to connect to your database, write your queries, get your autocomplete syntax validation, get some documentation about the language itself, because we don't necessarily know the language by heart, allow you to run those queries, visualize the results, and that allows to create this entire feedback loop around the querying experience of write, make sure you've returned it correctly, run it, make sure it runs sensibly, make sure it returns the right things, screw it up at some point possibly, rinse and repeat until you've got the right query ad nauseum, because there's always new queries to write. So with that in mind, I'm not here to sell a product, but it is in fact a little bit of what we're going to show today. So what I'm going to do is I'm going to show you, I guess, the graph database take, so to speak, on this type of product. And what you'll hopefully recognize very quickly is that we've built something that emulates a lot of what has been done in the relational database world for a really simple reason. Relational databases, they've probably been around for, don't quote me on this, like 30, 40 years. And the tools to support the usage of these has been around for 10, 15, 20 years. They have tens of millions maybe of users. They've been refined over several years. The user experience that has been built through these tools is battle tested. This is how we want to present databases to users so that they can work with them more efficiently and more effectively. And that comes both from the developer perspective, but also remembering someone is going to have to sell internally they're using graph databases, and they might have to show what that looks like. So what we've got here is our... Can you zoom in? Yeah, I can zoom in. It's a functionality that we have implemented, fortunately. So what we have here is G.V. You'll see on the left that we've got a bunch of database connections. I've mentioned we're compatible with a bunch of different technologies and language, but we're going to focus on GQL today. Right here, I've got my little querying screen. First thing first, run a query, see the results. That's like the most basic feedback loop. Now, because this is graph, we like to show a bit of graph visualization because that's what makes people click. It's nice and colorful and it's very easy to understand. be very quick on that because I think we've kind of covered a lot in the previous talk. But again, you can just quickly customize your information so that your graph visualization actually gives you something that is useful at a glance, so that you're not just trying to piece the information together as you go along. We offer different ways of visualizing the results. So visualizing the graph is useful from a sort of exploration perspective. From a demo perspective, it's especially useful, which is why I use it a lot. But sometimes you just want to just see the data and compare it quickly. So we're kind of coming back to surprise, surprise tables. Who knew? We've got results here that include a bunch of vertices with different labels. Sometimes I just want to see them as tables because that's just the most convenient format to compare their properties. Fine. Sometimes I want to just see things as the raw output from the database in JSON, etc., etc. So that's just giving the developer the tools to very quickly inspect what is going on with their query results across a variety of formats that are going to be adapted to what they're actually looking to do. Now, of course, if you're not running a query that is going to return graph elements, you're not going to need graph visualization, but you're still going to need to be able to see what the query is returning. And that's going to be a lot easier if you got a user interface that just puts it all in the one screen, as opposed to having to run a bit of code, maybe debug it, inspect the variables in your code, and just do the thing where you have to suddenly inspect those results that are super complex, and it gets really annoying and frustrating. And that allows, G.V allows you to basically just do all that, not only in the one place, but across several databases, writing multiple queries. So that's the basics, but we do some other things. So I've talked about GQL as a language. People are going to need to learn GQL as a language. Of course, it's very similar to Cypher. So there's a little bit of work that has been done, but there's always going to be beginners coming into graph databases, right? People are not going to go from Cypher to GQL. They're probably going to go from SQL to GQL. And so that means they're not going to have these concepts at hand. And there's a few things that we can do there. The first one, simplest one, is syntax validation. I know it sounds silly, right? But if you write something wrong, then you want to be told about it. And so having a query editor that tells you when you're not doing the right thing is useful. That's the first thing. And then the second thing is that you also want to be able to autocomplete results. Now, we've talked a little bit about schema handling. Schema handling with GQL is a bit of a challenge, but there's things that you can do. We can introspect the schema. Sometimes that's going to be through a schema API. Altigraph has a schema API. I can fetch that. I can use it in my autocomplete. I can then display useful information as I'm typing my queries. Like, for instance, hey, I'm going to filter some clients. What's in the client? What are the properties? What are the relationships? Having that information just right there in your face as you're needing it means you're not going to then need to go and look for it, which means you're going to be quicker, less frustrated, hopefully, as well. If you're not patient like me, I'm not patient, sorry, I phrased that wrong. It just basically gives you the means to write your queries more effectively, more efficiently, and to then be able to test them. Other things as well. What if I want to just know what a specific keyword says? Sorry, I've cheated a little bit on this one. I'll explain, right? There's no official documentation that I can just pull from GQL, maybe apart from Altpa's book, but that would not be very sensible to do that. So if you use a Neo4j docs as display, it's close enough, as some might say. But if I'm just writing my query and I want to know what each clause does, then I can access the documentation directly. And so that just means as I'm writing things, if I get my autocomplete in place and I look at my results and it's not doing the autocomplete, which is just demo magic right here. Normally would have shown the documentation. In this case, I decided not to, but it just basically means you've got access to what you need when you need it. The other thing is we've mentioned schema, right? Schema tracking can be difficult. GQL is going to work on allowing to see a schema. And so if we can get a schema from somewhere, that means we can display it somewhere else. It's cool to have the schema represented conceptually as a graph, but it's actually just a little bit more useful to then be able to visualize that graph. Again, we're sticking to the good old, ER diagram, because it's kind of a graph actually. And so that's very easy to understand. And again, someone that's used SQL that sees an ER diagram, that's not going to shock them. They've seen those with SQL, as it turns out. Therefore, we're again supporting the user experience, thinking about those people that are going to come from a non-graph background with non-graph expectations, potentially, by the way, into a graph kind of project where they might come into and be like, okay, where's the MySQL workbench? Where's the data grid? What's the whatever for this specific database? And this is basically where we come in. Now, of course, different databases have different degrees of tooling, but generally speaking, what we're finding is that a lot of them have something very basic or something that just doesn't exist. There's a whole bunch of other features available. I don't want to do a product pitch. I just want to talk about the actual problems that users are going to experience as they're going to interact with graph data concepts and the underlying languages. If you want to find out more about G.V itself, what it does, and a lot of details, I'll leave some links at the end. I just want to present the idea that as we're introducing new standards, we actually also need to introduce supporting tools so that users are going to come into it fresh, not like us having worked with graph database quite a bit. We'll have a helping hand to get into it without feeling like they have to learn the whole thing at once. So with all that, I'm just going to very, very quickly go back to my slides and wrap up. There we go. So useful links if you want to try G.V. I'm going to be clear, this is a commercial product, but we do a free trial. We've got a free version. If you've got a graph database, it's labeled part of the graph, chances are it's going to work with it. Chances are it's going to be better, sorry, humble brag, better than whatever tool the database itself is providing. That's common feedback that we get. Just don't quote me on it. Give it a go. You'll like it. You can find out what we're doing on social media. I'm always a ping away as well. So if you want to talk about your use case, or if you just want to say, hey, what if we could do this or that? Always happy to hear. And the other thing is, because I know we've got a few people that are, in the space, if you're looking to add GQL support in your graph database, talk to me, because then I can add support for your graph database with GQL on G.V. And if you're, say, not sure what to do on the user interface front, then, hey, you get to develop for free. And I get to have maybe some customers for me. We'll see. Generally speaking, we're just trying to be, vendor agnostic and as universal as possible. We're kind of this tool that wants to support the whole ecosystem. It's a good thing, it's a bad thing. Bad thing for me because it doesn't need to support like a lot of different languages, a lot of different concepts. I'm looking at RDF, for instance, right now, which is great. But it's not so great because I've been coming from an LPG background, so there's a lot of work there. And then, otherwise, the stuff that we've got there with Graph that's going to get released probably by the end of September, so you'll be able to try it with Graph. We're also working on other tools. I've talked about how we're drawing parallels from the relational database industry. The IDE is a starting point. That's what we've gone with. But there's other tools, data modeling, business intelligence, I think, to the extent as well needs to be discussed. And as a company, I guess, which mostly consists of myself and one and a half other person, that's what we're working on. So it will come over time. But yeah, that's basically all I've got for you today. If you got any questions, by all means.